So the content of my basic lecture is about network basic concepts and the devices that we normally see in our offices that that enable us to connect to our LAN one internet environment. We will discuss all the network media under this course, but uh, my discussion for this morning session is just an overview. If you will have to learn most of it once you are enrolled in the Rakuten Learning Hub portal, and all of our courses and lectures are uploaded in that portal. So we will also cover wireless networks, firewall, and the internet, and the basics of cloud computing itself. But edge computing and cloud computing are separate courses as well uh, in the Rakuten Learning Hub portal. So what is a computer network? It is a group of computers or nodes that are used and have a common set of communication protocols, and they are digitally interconnected for the purpose of sharing resources and providing other services to the network nodes. The nodes of the computer may include personal computers, servers, other network hardware, and other general purpose hosts. The interconnection of these nodes covers a lot, right? It's a broad spectrum of telecommunication network technologies. You can use physical wiring, optical, and wireless technologies in order to connect all of your devices in your computer network. And of course, the most important part is the communication protocol that is being used. Mostly nowadays, it's TCP/IP, which is the prevalent communication protocol and worldwide accepted. So these are the topics that will be discussed throughout the course. So this is a summary of the diagram how your local area network and your wide area network uh, are connected. So if you are in office, for example, and you're using a desktop or a PC and a laptop, normally you will have to connect to a switch. Normally, it might not be even a physical connection. Maybe you have a Wi-Fi wireless connection in your laptop. So normally you will have to search for the nearest Wi-Fi access points so that you'll be able to connect to your corporate network. So here we will, in this course, everything will be discussed. The the switch, the PC, the firewall, the router, and other LAN nodes. So what are the advantages of using the network or the LAN one connection? There are moments in any business when several workers may need to use the same data at the same time. So it's advantageous that you are all connected via a single or a VPN network or a corporate network. You can share peripheral devices, right? For example, printers. You can when there was the beginning of the IT industry in the Philippines, I remember vividly that once the end user will purchase a desktop, they will also purchase a printer with them. But nowadays, it's not the standard practice, right? What we do, we will have a shared printer on the floor or even on the building, and people, if they want to print, they will just have to go to that shared printer to get the document. And then we will also have the advantage of using personal communication. When we are connected in a network, when we can do video conferencing, right? Right now, what we're using is Zoom. Prior to Zoom, the prevalent video conferencing tool is WebEx, right? Actually, the creator of Zoom came from Cisco WebEx itself, and he just brought his code and founded a company called Zoom. And then, if we're connected to the network, we can also get rid of our standard telephone system, right? Right now, we're using voice over internet protocol. So if you have a laptop, you can have a soft phone application on your laptop. And at the same time, you can use that soft phone as your physical phone. Right now, our standard in the office is Microsoft Teams. So what we are doing is interfacing Microsoft Teams to our Cisco unified communications, and we're able to use the Microsoft Teams now as an ordinary telephone system using voice over IP protocol. And then it's also easy to do backup when you're connected to the network because you will also have a common storage area. So you will have big storage in your data centers, and eventually, if you do backup, you just have to upload it in your data center, or if you have a cloud environment, a public cloud, you can also upload it to the public or private cloud. So the networking nodes that are covered by the course starts from the NIC card, the repeater, the hub, the switch, the bridge, the router, the gateway, and the firewall. So all of these are covered by the course, but we will not, discuss them uh, one by one, right? Well, I'll just go over them because I think most of you are IT practitioners and you have an experience already of all these nodes. So for example, this is a physical construction of a network interface card, which is normally plugged into your desktop. If you're using a laptop, it's already a standard port in your laptop. Before, if you are not if your desktop or your laptop is far away from the switch, you need to use repeaters. Oh, and this is how a repeater looks like before. And then you also have your hubs. If you are also not close enough to the switch itself, before we have these devices called hubs, which is like a bridge going to your LAN switches. And then if you have so many users, normally all of your hubs are concentrated on the bridge, and eventually your bridge is the one connected to your main switch. And this is how a switch looks like with the workstation connected to them. And as you can see, you can share the printer because it's also connected in your local area network. And then lastly, in order to go out and be connected to the wide area network, you need to have your routers as well. And then sometimes we also need a special equipment which is called a gateway. So why do we need a gateway? For example, if you have a specific example for me is if you have a PABX system and you're still using traditional telephone networks such as an ISDN, normally we will have to have an interface between your corporate network, which is digital, going to your analog circuits, right? So normally we have a gateway, and for this purpose, if it's going to be connected in your PBX, we call it a voice gateway. And then of course, after the router, you have your firewall to provide protection prior to going to the internet. And then we come to the wireless networks. So what are the most common wireless networks that we use? Normally, it would be Bluetooth and Wi-Fi, right? So for Bluetooth, normally we use our headsets and some other devices, maybe calendar, portable calendars to be connected to your laptops, and we normally use Bluetooth for that. But for the overall corporate network connection, we use Wi-Fi. So if you will take a look at your offices, normally on top of the ceiling would be your wireless access points, right? Those wireless access points are the ones directly connected to your LAN switch, and you're able to access the Wi-Fi access points using radio waves. For Bluetooth, the standard is a short-range wireless technology, and it would be in the UHF radio wave. It's from 2.402 to 2.48 gigahertz. And it's covered by the IEEE standard Bluetooth 802.15.1. For Wi-Fi, the standard for wireless fidelity is the one we use in our local area network. So the speed varies from 10 up to 100 Mbps, depending on the Wi-Fi or Wi-Fi access point that you have installed in your office. This is based on the IEEE 802.11 family of standards. And normally, you will be connected via your access points. As I've said, these are the devices that you see in the ceiling of your offices. Nowadays, we have other improvements in the Wi-Fi connection. We call it high density Wi-Fi connection. So in the past, we just install a few access points, right, on the floor. But the problem is sometimes your laptop has limited coverage, and you will have difficulty connecting to the network because the access points radio signal does not reach your receiver of your laptop. So 2 years ago, for example, in our corporate environment, we implemented the high density Wi-Fi. So instead of a few Wi-Fi access points, we will now introduce as many as possible Wi-Fi access points for each floor, so that wherever you go in the office, from one corner to the other corner, you are covered by the Wi-Fi connection. So once you are connected to your local area network and you pass by your router, you're now able to connect to the internet, right? And that's what's important because everything now passes through the internet. So the simplest definition of internet is it's a network of computer networks, but this time it's a worldwide connection. And the communication, of course, is via TCP/IP, and the transmission is usually via packets. So this is how your connection travels through the internet. Normally, you will have your uh, carrier or ISP provider so that your routers can connect to your ISP and eventually go out in the wide area net. The course is also tasked to discuss about cloud computing, but as I've said earlier, this is a separate course in Asia Open LAN. And the benefits of having a cloud environment is that you don't have to have capital expenditure, but what will happen is that you will have operating costs because the hardware are now going to be shouldered by your cloud provider, and you will just pay a fee to access those hardware in their environment. So an example of this would be AWS, Azure, and Google Cloud. And it's very easy to scale when you are in the cloud environment. Actually, this is the major thrust of big modern corporate environment nowadays. Because if you're using the cloud, it will have so much savings at your end, and the development of the applications would be straightforward because most of the cloud providers have already APIs that can help you with your programming and coding work. And at the same time, if you have a good contract with your cloud provider, they will guarantee the service level agreement and the availability of the system as high as 99%. Because, for example, Google and Azure has so many data centers and servers scattered around the world. I think it's about more than 1,000 computers, and they have so many, at least 300 to 400 data centers scattered around the world. As you can see, the benefits, you can have scalability, elasticity, you have availability, which is reliable, you have performance optimization, and access is very easy. So now we're familiar with all the nodes in our network environment. But the course also covers the protocol that is being used in our computer environment, right? And normally all of them, in order to be able to use the TCP/IP protocol, all of our devices that are connected to our network will have an IP address. So nowadays we have this technology which is known as the dynamic host configuration protocol. And this is the one loaded in your servers. And once you are connected to the corporate network, it will recognize already the MAC address of your device, and it will automatically assign an IP address to your device. Before, before the DHCP technology, if I remember it correctly, we will do static IP addressing. So as a network engineer, will be the one assigning each IP address for each of the department. And once they have a new laptop, you will provide them the exact IP address, and you will have to do it or configure the laptop manually. But nowadays, once you're connected to the network, because of this dynamic host configuration protocol, the IP address would be automatically assigned to you. So this course will also cover the IPv4 classes of addressing. And I think the best way to show this is if we will watch this video that I have included in the course.
So what is ClickUp? ClickUp is an all-in-one productivity software where you can manage everything and anything.
Address. It's an identifier for a computer or device on a network. Every device has to have an IP address for communication purposes. The IP address consists of two parts. The first part is the network address, and the second part is the host address. There are also two types of IP addresses. The first one is the most common one. It's called IP version 4. And a second type is IP version 6. IP version 4 is the current version of IP addresses. It's a 32-bit numeric address written as 4 numbers separated by periods. Each group of numbers that are separated by periods is called an octet. The number range in each octet is 0 to 255. This address version can produce over 4 billion unique addresses. In the world of computers and networks, this IP address in this format here is meaningless. Computers and networks don't read IP addresses in this standard numeric format, and that's because they only understand numbers in a binary format. A binary format is a number that only uses ones and zeros. The binary number for this IP address is this number shown here. This binary number is what computers and networking devices actually read. So the question is, how do we get this binary number from this IP address? IP address 4 is made up of 4 sets of 8 binary bits, and these sets are called octets. The bits in each octet are represented by a number. So starting from the left, the first bit has a value of 128, then 64, then 32, and so on, all the way down to 1. Each bit on the octet can be either a 1 or a 0. If the number is a 1, then the number that it represents counts. If the number is a 0, then the number that it represents does not count. So, by manipulating the 1s and the 0s in the octet, you can come up with a range from 0 to 255. So, for example, the first octet in this IP address is 66. So how do we get a binary number out of 66? First, you look at the octet chart, and you would put 1s under the numbers that would add up to the total of 66. So you would put a 1 in the 64 slot. So now you already have 64, so we need 2 more. So let's put a number 1 in the 2 slot. So now if we count all the numbers that we have 1s underneath them, you would get a total of 66. All of the other bits would be zeros, because we don't need to count them since we already have our number. So this number here is the binary bit version of 66. So we'll put that number down here. So let's do the next number, which is 94. So let's put a 1 under 64, 16, 8, 4, and 2. So if we were to add all the numbers that we have 1s underneath them, we would get a total of 94. And since we don't want to count any of the other numbers, we just put zeros under the rest. So the next number is 29. So let's put a 1 under 16, 8, 4, and 1. And when you add all the numbers up, you get 29. And our last number is 13. So let's select 8, 4, 1, and when you add those up, you get 13. When the internet was first developed, programmers didn't realize how big it would become. They thought that IP version 4, which produced over 4 billion addresses, would be enough. But they were wrong. IP version 6 is the next generation of IP addresses. The main difference between IP version 4 and IP version 6 is the length of the address. The IP version 4 address is a 32-bit numeric address, whereas IP version 6 is a 128-bit hexadecimal address. Hexadecimal uses both numbers and alphabets in the address. So with this type of address, IP version 6 can produce an unbelievable 340 undecillion IP addresses. That's the number 340 with 36 digits after it. So as you might have guessed, IP version 6 is more than enough for the foreseeable future. So as stated before, IP version 6 is a 128-bit hexadecimal address. It's made up of 8 sets of 16 bits, with the 8 sets separated by colons, as you can see here. So in a similar way that we converted an IP version 4 address to a binary number, this is how we convert a binary number to a hexadecimal address. In an IP version 6 IP address, each hexadecimal character represents 4 bits. So we have to convert 4 bits at a time to get one hexadecimal character. So starting from the beginning, we convert the first 4 bits and put those bits up there against our 4-bit chart, which includes an 8, 4, 2, and a 1. So if we count the numbers that we have ones underneath them, you wind up with a 2. So a 2 is the first hexadecimal character in this IP version 6 address. So let's do the next 4 bits and put those under our 4-bit chart. So if we count all the numbers that we have ones underneath them, we have a 4 and a 2. And if we add those up, we get 6. So a 6 is the second hexadecimal character in this IP address. So let's do our next set of 4 bits. And if we add all the numbers that we have ones underneath them, we get a total of 13. But the problem is, since 13 is a double-digit number, we cannot use a double-digit number to represent 4 bits. And that's because in a hexadecimal format, double-digit numbers have to be represented with a single alphabet, which is A through F. So in this case, we have to use another chart for any 4 bits that the sum is 10 or higher. So in this chart up here, if the sum was 10, then we would use the letter A. Or if the sum was 11, then we would use a B. But in this case, our sum is 13. So now for the third character in our binary number, we would put a D. So in our last example, let's do the 4th set of bits. And if we add those up, we get 11. So we have a double-digit character again, which means that we have to convert it to a single character alphabet. So if we look at our chart up here, 11 converts to a B. So the first 16 bits of this binary IP version 6 address converts to the hexadecimal address as 26DB.